All right, guys, so as I described in the email that I sent to you, I wanted to make sure that we had time to do board work this week, and I was worried that some of these examples might take too long. And so this is the video on force and pressure, calculating force times pressure. At this point, we should have talked about density, centroids, and work. And so this is just going to be yet another physics variation of the same ideas that we've been kind of messing around with. So to tackle, so this is 8.5, and specifically it's the force and pressure section. And there's a couple of formulas we get right off the bat. First off, note that pressure is equal to mass times, or mass density. Yeah, let me just rewrite it. Okay, pressure is equal to mass density times gravity times depth, or as we're gonna usually write it, delta GH. And the force on, well, I'll say this, I'm gonna add this to a constant force constant pressure over an area, and I should say over a given, there we go, given area, yields that force is equal to pressure times area. That can make sense if pressure is this downward force on something, and then I apply it uniformly to some area surface, then force should be equal to the pressure scaled by the area of that surface. We are generally going to use, so note that our units are going to go as follows. So density of water, the force, the area, and the pressure. And this is in scientific units, and this is in British. Okay, so density of water is equal to 1,000 kilograms per meter cubed. British is 62.4 pounds per feet cubed. Note that British, this includes gravity. And this is why I said in class that British units are actually easier sometimes. When we're doing these pressure problems, if it's in feet and stuff, and then we switch to, if it's water in terms of feet stuff, and we switch to density, because density for British units includes gravity already, we won't need to multiply times gravity to get that in there. So our formula up here won't include G for British units, because British units, the G is already included in the delta. Okay, and so then we have the force, if we have newtons, and we have pounds, and area here will be meters squared, and here would be foot squared, and the pressure is Pascal, newtons per meter squared, and the pressure here is pounds per feet squared. So when a lot of these pressure problems will involve water, Actually, I think pretty much all of them. And when they do, these are the units you're going to use. So let's just go ahead and tackle one of these, right? So let's look at, this is example. In 1912, oh, this is technically in the book, this is example 7. So in 1912, the ocean liner Titanic sank to the bottom of the Atlantic, which is 12,500 feet, basically 2.5 miles below the surface. We want to find the force on one side of a 100-foot square plate at the depth of the Titanic if the plate is A, lying horizontal, or B, lying vertical. And I think that's all I need to set up for this. Yeah,